Welcome back. Today we'll talk about database replication. So in the previous video, that when we talk about system design, we did talk about the load balancing and what is the benefits of load balancer and what are the improvements in terms of the availability and scalability that we got when we use a load balancer. Today we want to talk about the database. Currently we have in our system one database, and when our servers try to send a lot of requests to database, our database might get overwhelmed. Secondly, if our database get failed or have something, we will lose the full data that we have because we have only one data. So we have two problems. The first one, we have a single point of failure. So when the database server fails, we can't reach our data anymore. The second is that we need to scale. So when we get too many requests from the servers to our data, we need to find a way to make sure our system will handle the data, the traffic that comes to it. So this where the database replication come into play. Let me first clear everything here. So database replication is a process of copying and maintaining database objects such as tables in multiple databases that are part of distributed system. Replication ensures data consistency and availability across different locations or systems. It is crucial technique for enhancing performance, fault tolerance, and disaster recovery capabilities. So why do we need to have a database replication? We said that high availability and fault tolerance. So we need to ensure that data is available even if one of the database fails. So if one database fails, right now we have only one server. So when this server fails, everything fails. The second thing, we need to make sure that we have a failover, so a failover mechanism. So automatically we need to switch to a replica in case of primary database failure, ensuring continuous operating. Also, it's good for scalability. So we need to distribute read queries across multiple replicas and reduce the load on the primary database and improve performance. And also it's good in disaster recovery. So we have data backup. So we provide up data copies of data that can be used recovery in case of data loss. And we will use what we call a master slave architecture. So how it will look like. So we have a master, and we have, let me just delete this. And we will have two slaves. Let's for now have two slaves. Let's call it slave 0 and slave 1. And let's add another one here to this. And it will replicate all the data. And as well here, it will it will take the data as well from the other slave. Okay, that looks good. So what's going on here? So in a master slave database, as you can see here, we have the master, which the master database handles the write operation. So inserts, updates, deletes, edits, everything like that, that we perform some write operations on data. We ensure data consistency and ensure data integrity. So the master-slave database architecture, also known as a primary or secondary or leader-follower, is a common replication strategy used to improve data availability, reliability, and performance. This architecture involves a primary master database, which is this one, and also and also uh, and also have secondary or slave databases that handles read operations. So for now, our system could be high available. So when the server try to make any read request, it will go through the master, and the master will replicate all the data that comes to it to the slave 0 and slave 1. And when the slave 0, for example, was failed due to like a disaster or something like that, slave 1 could take all the read queries and still serve the servers and the backend and the client with data. If the master was gone, if the master was gone, that one of the slaves will be recruited to be the new master. And when this one will be the new master, it will handle all the write operations, and it will, after that, it will replicate to the slave 1. So as we said before, the master is handle the primary, the write request, the write operations, and the slaves handle read operations to offload work from the primary database and receive updates from the primary database to stay in sync, and also typically read only prevent data conflicts. So it's handle the read. And also there is another thing, which is in the read heavy systems, this architecture is way more better for databases because we distribute the loads and across multiple servers. So right now S0 and S1 hands the read operations, and it's not handled with one server. We have replication. So we said that we synchronize. Let me just, before talking about the synchronization, let's just delete everything. We synchronize replications with changes are replicated to secondary databases or slave databases with a slight delay, ensuring a higher performance but eventual consistency. We have synchronous replication, so the changes are replicated immediately, ensure in the real-time consistency, but potentially impact the performance. We can talk about the mechanism of how the replication is working, but for now we can know that every write request or write operation that hits the master, it will be replicated to S0 and S1 to make sure that they are as consistent as possible with the client. So the benefits of using a master-slave database: first, we improve the performance. As I said before, the read queries are distributed across multiple secondary databases or slave databases, reducing the load of the primary database, as well as the scalability. So it's easy to scale out read operations by adding more secondary databases. So if we have more load, we can add more. I need to improve myself in just drawing. So we can add more slave databases. It's great as well at high availability. So secondary databases can take over read operations if the primary database fails. And also it can take over the write operations. If the master fails, they can take the write operations, like one of the slaves could be recruited to be the new master. It's great at data redundancy. So secondary databases serve as real-time backups of the primary database. And yeah, there are some challenges that comes to this architecture with this, the consistency and the complexity and the single point of failure. But also this one is not that common to talk about. But in terms of system design interview, you don't have to need all about the ends, all the inside details about the master-slave database. You need only to know it on high level. So for now, you need to know that master-slave database, first, it improves availability, it improves the performance. The slaves can handle only read operations, and the master handle the write operations. And whenever the master was down, one of the slaves will be recruited to be the new master. And when one of the slaves went down, all the requests will be redirected to the slave 1 instead of the slave 0. So that's it for this one, and I hope you like my content, and that's it.